really important that you know your rules and your shortcuts. So last lesson, I guess we focused mainly on looking at different bases, but it's all the same thing, okay? All of our log rules, whether it be base 10 or what we looked at last lesson was the natural logarithm, ln. I could rewrite all of these rules with an ln instead of a log, okay? I could rewrite all of these rules with log base 3a plus log base 3b will equal log base 3ab, right? So they've just done it like that to keep it nice and simple. I think this one is quite helpful. Okay, so just to recall, when we've got our different bases, so everybody, you got your calculators, grab them out. So if we say log 10, we know that equals 1. If we change our base to, let's keep it log 3 of 10, we will not get that that is 1. Agreed? Right, the reason that this one works is because what we are saying, I guess I shouldn't have used 10, but anyway, what we're saying is we're going 10 to the 1 equals that thing there. So I like this little loop, this little circle bit. So if I've got log, if it's base 3, and we know that that equals 4, what we're saying is we're going around here, around and around, so this thing here will be 3 to the 4, right? So do you all agree then that log 3 of 81 equals 4? And I hope that you do agree with that. Is everyone happy of how to change the base on their calculator? So if someone said no, good. Okay, so in a normal calculator mode, hit math, and then you've got your F2. You press that and you can change your base. Okay, so go 3 and 81, and away we go. Oui? So I'm going to give you some questions, or the textbook will give you some questions where we mess around with this sort of thing. So it could be something like log, I don't know, let's go x 7 equals, give me a number, 5, right? What's x going to be? So do the, it's not going to be 5, we're doing that little doodad, so that means x to the 5 must equal 7. Does that make sense? So how do I now find x? Do I need logarithms? No, we're not finding an unknown power. So how do we get rid of a power of 5? You take it to the 5th. So this will be the 5th root of 7, right? Or how else can I write that? 7 to the what? Good. 7 to the 1 over 5. Make sense? Right, I could do this and stick the x somewhere else. So you guys make this question for me. Log, Karen, choose a base. 5. Yep. Shall we put the x here? So it would go x and equals 90. Oh, good Lord. 90. So again, you're doing your little arrowy thing. I don't know why I chose yellow. That's not a good combination, green and yellow. Right? So that goes zoop and zoop. So therefore, what's x going to be? 5 to the 90. And there's no way that you'd work that out. Yeah, that's not. Okay, so are we happy with that? We are also, last lesson, so I don't know, I'm glad you're sitting down because you guys missed a massively difficult situation. We looked at the natural logarithm, ln. And if you look at your calculator, here's my calculator. Here's our ln here. It's not in, it's ln, natural logarithm. Now, remember log base 10? How did we get rid of log base 10? How do we get rid of the log base 10? We went 10 to the, right? So if I had, this is just summarizing everything, and don't worry, I'll save this so you don't have to write all of this stuff down. If I've got log log 7, this case you're going, I need to get to x. So you're telling yourself, or you're asking yourself, well, I want to get to this x here. How do I get rid of log? Right, this is when you have to go 10 to the, yeah? Maybe I don't put the x, maybe I just go 10 to the power. 10 to the, and if you ever forget, if you're going too many, look, it's right there. Your calculator actually tells you. You got to love it. So this becomes, when I go 10 to the log, gone. I'm left with x take 4 equals 10 to the minus 2. Capiche? And let's get rid of the take 4, add 4, yeah? And so then, if we have the natural logarithm, it's the same thing. How do I get rid of an ln? Well, instead of 10 to the, it's e to the. They undo each other, right? And it's just a graph. So if we go back and look at our graphies, which is one of the things I would like you to have a look at today. If we look at 2 to the x, nice exponential graph, 2 to the x. We looked at this right at the start. If we now go e to the x, it's still that exponential. What's its y-intercept? It's still 1. Why? Because anything to the power of 0 is 1. Okay? So it works the same way, where if I've got ln of x equals 7, how do I get rid of, I hope you're okay, how do I get rid of ln? We e it. So e, exclamation mark, e it, right? E to the, you get x equals e to the 7. Oui? And now let's go full circle, right back to why are we messing around with logarithms in the first place? Why do we need logs? Pardon? To deal with exponentials when your unknown is a power, is an exponential. That's why we need logs. Yeah? And look, it's cute that we started with logs, as in L-O-G-E. So go back to our beginning. 2 to the x equals, well, we know what 8 is. So let's go to the 10. No, let's go to the 12. Okay, now we know 2 to the 3 is 8, and we know 2 to the 4 is 16. So solving this, we know that x is going to be somewhere between 3 and 4. Do we agree? And you could guess around the place. Right, we can then go, how do we solve? We just log both sides. Agreed? So we're going to go log 2 to the x equals log 12. That allows us to now bring our x downstairs, because that's one of our rules that we love the most, correct? So we end up with x, I better do it step by step, Ange. X log 2 okay, so x equals log 12 over log 2. And you're going, what is this whole ln business? Well, you could do the same thing. Instead of going log both sides, I could take ln of both sides. And I'm probably yelling into the microphone. Sorry about that. That becomes x ln 2. Now your sound's gone crazy. And we end up with x equals ln 12 over ln 2. Are we all agreed? Yeah? And you're going, yeah, big whoop doop. Here's the bit I love. Grab your calculators. And I've done this with some of you, and you should go, oh, she's already done this, but still, appreciate. We ready? Log 12 equals ln 12 equals. They're two different numbers. Agreed? Yes? Did I do this? I mean, I can't contain my excitement, but anyway, log 12 over log 2. And I'm not bothering you to go, you know, log 12 and log 2 and ln2 are going to be two different numbers as well. Oui? So we get this? Yes? And now, ln 12 over ln 2, drum roll please. Oh, ha-ha! Because it's all about your ratios, okay? You get the same answer. So when it now comes back to this, does it matter if you use log or ln? Does it matter? No. You might go, do you know what? I'm writing one less letter. So I'm now going to use ln. I don't want to ruin the surprise, but in year 12, you do not use logs anymore. All of a sudden, they just go ln. So if you want to get to that now, feel free. If you have an inkling of fondness for log base 10, well, you can write log. Up to you. Does that make sense? Halfway through this lesson, we're going to have a little bit of a look and remind us about the graphs of, well, not remind because you haven't looked at the graphs of logs yet, but have a look at their properties. Remind you about the graphs of exponentials. Oui? Oui. So, what are you doing? You're finishing the chapter. If you wanted to start the reviews, you can, and I made something for you. Exercise what? 13b. Oh my God. So I'm surprised that no one else has asked about 13b question 6, which reinforces, I think some of you have actually possibly skipped 13b. So you don't have to go back and do it immediately, but I really do like, that was a good question. Exercise 13b question 6. So please go back and make sure that you've had a go. It's not long-winded, it's short, sharp, shiny, it's pretty cute. It's just about how to solve things. Now, a couple of questions on the board that I just want to make sure everyone is doing nicely. Some of you might have already worked ahead and done it, but the key here, especially for the last two questions, is can you do them with only using your calculator once? Also, questions like this one, in a moment will show you I could do a show that x equals blah-de-blah-de-blah. So, with the first question up here, it's from some other exercise, but how are we going to do that? How do I get rid of the e? Right, because it's an e, I'm going to ln, not log, but I understand what you mean. So I'm lning both sides, so I end up with 2x equals ln 18, and some of you might be going, yeah, why is she doing this? For this reason. When we solve now for x, to get rid of the times 2, we divide by 2. So you can write it like this. You could write it like this. Any other way you could write it? So dividing by 2 is the same as timesing by half. So you can also say this is ln 18 to the half, which is the same as ln root 18. But what you cannot, and what you should never do, is you cannot write this as ln 9. Okay? You cannot say it's 18 divided by 2 because that doesn't have the ln thing there. Okay? If it did have, so I'm going to put a big is not equal to ln 9. If you did have ln 18 over ln 2, unless, like we were talking about before, you can't write 18 as 2 to the something, I can't simplify that. That's it. Okay? And not to be confused with ln 18 over 2, and yes, you could say that as 9, but remember that's the same as ln 18 take ln 2. So just be really careful with some of your simplifications as you're going along, okay? So that was the point there. So as you are going along and doing some of these questions, do make sure that you understand what they look like. And by the way, would I have left it like that? I could now simplify that even more. That would be ln 3 root 2, which could be ln 3 plus a half. Anyway, you could keep on going, as long as you never write it as ln 9. Are we happy with that? Okay, looking up the top over here. I'm going to run out of room, aren't I? Never mind. This is why I love my board. Yeah, baby. 4 times 5 to the x take 3. What is going to be your first step there? Well done. Divide by 4. Now, I should have chosen 3 actually. Never mind. When you do this, you've got options. You can be so bold as to even leave it as 14 over 4 and not cancel it to 7 over 2. And I know some of you are going, well, what, Sheree? Sure. Some of you are probably going, oh, why couldn't I just put it as 3.5? As I said, if it had been maybe 13 over 3, you wouldn't simplify that as a decimal because then you're rounding off. So like with sine, cosine, with all your trig stuff, you want to keep exact as much as possible. Same with your logs. You only want to use your calculator once. All right. Because some of you are using ln, I'm going to go ln. So we're going to ln both sides, correct? Because we are probably just getting used to it, you might write that. The more that you do of these, you probably might jump to this step here where you've got x take 3, ln 5, because isn't that the whole reason that we logged in the first place? Okay, what will you do now? Divide what?
Divide the right-hand side by ln 5.
Fair enough. Okay, so Dylan's saying x take 3 equals ln 14 over 4. Divide by ln 5 to get rid of the times you divided. How do you get now rid of the take 3? Then you add 3. Okay. Good. You might be asked to show that that equals something a little bit different, because in a moment you'll see one of your other options could be that you could also expand your brackets. Okay, because what we're going to see now is that that method might not work with one that looks like this. So, can you please write this one down in your book somewhere? And we're going to do this one together. Oh, I heard log first. Who said that? Okay, Al, you win. But again, you could ln, you could log, it doesn't really matter. So again, first thing we notice is our powers are unknown. So that means we're going to have to use logs. Brody, Hamish, you right? Yep. Okay, we check the bases. We can't put them in the same base because obviously if we could, that would make our job a lot easier. So no base is the same, away we go. So we're going to log both sides. Are you happy? The whole reason I'm logging is to bring this whole power down. So is everyone okay? Save you one line of work. Would you agree with this statement? And you're being very good by using the brackets. You'd be a sloppy jalopy if you did not include the brackets. Correct? So good technique from last question to get rid of that times we divided. But you can see in this case it might be a little bit ugly if we got rid of that times log and we divided. Yeah? So what we're going to do, believe it or not, is expand the brackets. So 2x times log 11 becomes 2x log 11 minus 3 times log 11 is 3 log 11, and we can do the right hand side as well, correct? Now it looks ugly, but it's actually not. If you think about the fact that like 3 log 11, that is just a number. It's a hideous number, but it's still a number. So if I had 2x times 5 plus 12 equals x take 3, what would you do? Get all your x's on one side, wouldn't you? And you'd go, well, 5 2s are 10, so you'd say 10x take x equals minus 3 take 12. Do you agree? Now, you guys are so good that in your heads, you would go 10 take 1. You're sort of ignoring the x's, aren't you? You go 10 take 1 is 9. So, but technically, you're pulling out that x as a common factor and you're going 10 take 1. Agreed? We're going to do the same thing here. So we're going to get our x's on one side. So it's going to be 2x log 11 minus x log 7. Are we happy with that? That was a plus here, so when it comes over, it's a minus. The 4 log 7 can stay where it is because it doesn't have an x. And this minus log 11 goes over the other side and becomes plus. Hideous, but looks impressive, does it not? So now this one here, we're going to pull out our x as a common factor. So what will go inside my bracket? I pull out the x from here. What am I left with? 2 log 11. I pull out the x from the next term. What am I left with? Now, again, we see the logs, they're just a number, right? Hideous decimal number, but still just a number. How do I get rid of that times? Bloody, bloody, blah. Divide by bloody, bloody, blah. So therefore, x equals 4. I mean, and step back and look at what you've written. Like, it looks massive, but is it really difficult? I don't think so. It's just basic algebra, but you've chucked logs in there. Do you agree? But if I left this on the board, I've got year 9's last lesson. If I leave this on there, they'd be very scared. And now, I will. And now I pop it in my calculator and I will round it off to 2 decimals or 3 decimals. Actually, could I go 3 decimal places? Do you mind? 5.25. 5.256? 5. Good grief. Okay. So, I mean, we can do over and over if you want, but it's the same thing, right? Log both sides, bring it down. Just make sure that you're using brackets and expand. Put all your x's on one side. Pull x out as a common factor and away you go. Okay? Look, 10 minutes to go. Time flies when you're doing maths. The only thing that I wanted to do today was make sure that everyone was happy with their graphing of those weirdo questions, but also to go back and just refresh about the properties of the exponential and the log. So we'll look at that on Thursday. If you wanted to get ahead of the game, by all means, look at your graphics calculator and graph some of the log functions and play around, but we'll be able to do it in 5 minutes, I reckon. And of course, you can look at your worksheet, but ignore the one that has the graph functions. And of course, you've got your review sets.